Good day, students. Welcome to our today's lesson, Electromagnetic Spectrum. And I'm your grade 10 science teacher, Mrs. Mary Joy I. Escamillas. Our most essential learning competency is we're going to compare the relative wavelengths of different forms of electromagnetic waves. Did you call your friend using your cell phone today? Or did you listen with your favorite song using the radio? Or maybe did you cook your breakfast using the microwave oven? What did you notice with those human activities? All of those human activities have in common. They all use electromagnetic waves. Always remember that a wave is a disturbance that transfers energy. Electromagnetic waves are formed when an electric field comes in contact with magnetic field. Thus, waves combining the electric field and magnetic field will form the magnetic waves. Electromagnetic waves have the electric field and the magnetic field are perpendicular to each other. Thus, they are on the right angle and they are perpendicular to the direction of electromagnetic wave. Electromagnetic waves can travel through a vacuum because they do not require matter to exist. It means that it not only travel in air and solid materials, but also through a vacuum of space. All electromagnetic waves travel at the same speed with a constant velocity in a vacuum, which is 3 times 10 is to 8 power millimeter per second. The electromagnetic waves are often arranged in order of wavelength and frequency, and what it is known as the electromagnetic spectrum. This means that the continuum arrangement of different types of electromagnetic waves like the radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma ray is composed of what we call electromagnetic spectrum. Electromagnetic spectrum, because electromagnetic waves travel at the same speed. If the frequency of wave changes, the wavelength also change. Thus, the longer the wavelengths, the low frequency. The shorter the wavelengths, the high frequency. With a low frequency, it has a low energy. With a high frequency, it has a high energy. Thus, it means that wavelength is inversely proportional to frequency and energy. Electromagnetic wave with more energy is classified as ionizing radiation. One of the examples of this is the X-ray, and the other one is the gamma rays. While electromagnetic waves with less energy are classified as non-ionizing radiation, which has the example of radio waves, microwaves, infrared, visible light, and the UV rays. Now, let's talk about a brief history of electromagnetic waves. Let's talk about scientists who made a significant contribution in resolving how electromagnetic waves behave. Let's talk about Hans Christian Oersted, a Danish physicist and chemist in 1820, discovers electromagnetism when he noticed that an electric current flowing through a wire deflects the pull of a magnetic field. Through this, he showed how a current carrying wires behaves like a magnet. Next is André Marie Ampère. In 1826, French physicist and mathematician André Marie Ampère discovered the force between two current carrying wires. The attraction is magnetic, but no magnets are necessary for the effects to be seen. He also formulated the Ampère law of electromagnetism. Next, we have James Clerk Maxwell. In 1876, English scientist James Clerk Maxwell formulated the electromagnetic wave theory, which says that an oscillating electric current should be capable of radiating energy in the form of electromagnetic waves. These scientists also contribute a better explanation of electromagnetic waves. It's also a better contribution with the explanation of induced electric and magnetic field opposes the flux producing it. Next one, we have Michael Faraday. In 1867, British physicist Michael Faraday is best known for his discovery electromagnetic induction. He found out that when an electric current passed through a coil, another very short current was generated in a nearby core. And he also have a fundamental contribution to electromagnetic theory of light. And the last one, we have Heinrich Hertz. In 1880, a German physicist, Heinrich Hertz, he proved the existence of radio wave, the unit of frequency of a radio wave. 1 cycle per second is named the Hertz in honor of his name. He's known as the radio waves. And he also possesses all the properties of electromagnetic waves. And before I end this lesson, I want to read to you a quote. What is a soul? It's like an electricity. We don't really know what it is, but it's a force that can light a room, by Ray Charles. I hope you learned something, student. Thank you. Until next time.